In this video, we're going to explore colligative properties and then see how the vapor pressure is a colligative property. In this video, we are going to explore colligative properties and more specifically, vapor pressure. So a colligative property is something that only depends on the number of solute particles in the solution and not the identity of those solute particles. So if we look at sodium chloride is soluble in water, and when it dissolves in water, it completely dissociates. It is a strong electrolyte. When it breaks up, it is going to have two particles in solution. Magnesium chloride, on the other hand, is going to create three particles or ions in solution because it has one magnesium and two chloride. Now, molecules do not dissociate. They are non-electrolytes, so they don't break up. And for that reason, there's only ever going to be one particle in solution. The vapor pressure really only applies to liquids. And it is the pressure that exists directly above the liquid right here. And then the gas molecules can keep rising. But what happens a lot is you get this equilibrium situation where the liquid will leave and become a gas, but then the gas particles will come back into the liquid phase. So this vapor pressure is the pressure exerted by the gas molecules that escaped from the surface of the liquid. So if it's easy for your gas molecules to escape, then your vapor pressure is going to be higher. If it's harder for them to escape, then your vapor pressure is going to be lower. We can relate that to IMFs. So strong IMFs are going to have lower vapor pressures. If your molecule has weak IMFs, then it's going to have a higher vapor pressure. When you heat a molecule, it is going to gain kinetic energy, the energy of movement. So when there are more molecules that are moving faster, then more molecules will escape as vapor, and the vapor pressure is also going to be increased. So here I have a solution at 20 degrees Celsius, and I can see the different gas particles that are present. If I increase the temperature to 30 degrees Celsius, that kinetic energy is making things move a lot more, and I get more gas moving out of the liquid. So let's look at some example problems with vapor pressure. Notice these first two examples are the same as the ones before. So we already know that hydrobromic acid, hydrochloric acid, and hydroiodic acid are polar molecules. So they have dipole-dipole forces as their dominant IMF. HF has the ability to hydrogen bond. So it is going to have hydrogen bonding as the dominant IMF. So when I look at vapor pressure, if it's really hard for me to take that those two molecules and separate them and get them into the gas phase, then that's going to give me a lower vapor pressure. HF is going to have the strongest IMFs, so it is going to have the lowest vapor pressure. A, B, and D all have equal IMFs, so in this case, we have to look at size. HCl is the smallest, so it is going to have the highest vapor pressure. We already figured out the IMFs present in the second problem. We have dipole-dipole for A, dispersion, London dispersion forces for B, dipole-dipole for C, and hydrogen bonding for D. So the strongest IMF is going to give way to the lowest vapor pressure, and the weakest IMF is going to have the highest. So B, methane, has the weakest IMFs, so that means it is going to have the highest vapor pressure. Whereas D has the strongest IMFs, so it is going to have the lowest vapor pressure. We can also look at boiling point and make some predictions about vapor pressure. If I have a low boiling point, it means that the liquid molecules are more likely to leave and go into the gas phase. If I have a higher boiling point, then they're not as likely to go and move into the gas phase. So water has the highest boiling point. So that means it's going to have the lowest vapor pressure. And it has the lowest vapor pressure because it takes a lot more energy to separate those water molecules. When I look at the rest of my examples, D, C2H6O, has the lowest boiling point. So that means it's going to have the highest vapor pressure. It's going to be easier for those liquid molecules to change to the gas phase.